Okay, so welcome to the lecture, chapter 21, the lecture over solid, toxic, and hazardous wastes. So everything we do with our society revolves around production of energy for our lifestyles, whether it's electricity or gas or whatever it may be. And in the process of our lives, we produce waste. Wastes come in all different forms and types and varieties. The challenge is identifying the waste type and figuring out how we can produce waste that minimize the environmental impact that it has. And that's going to be the thing we want to think about and discuss and look at in this chapter is what are waste products that we produce, and how can we, as they say, reduce, reuse, and recycle to minimize our waste production and to try to shrink a thing called the waste stream. So we'll get into that during these lectures. So let's first take a look at the U.S. and look at our domestic waste production. Now we have two categories of waste production in the U.S., just keeping it easy and putting in these two categories. Category one is called municipal waste. Now this is what comes out of our homes every day. Every day we produce roughly 4.4 pounds of waste a day. This goes into your trash can. Drag it to the street or take it to the dumpster or wherever. About 4.4 pounds per person per day is the average. Now you may say, hey, I only took out one bag this week for our whole family. Fantastic. That's great. But what happens later in the year if you throw away a TV or, well, my refrigerator went out and I had to buy a new one. So again, this is an average. Household commercial waste equals about 4.4 pounds per person per day in the U.S. The goal is, can we lower that number? The second category of waste production in the U.S. is what we call industrial waste. This is the waste that comes from mining and mineral production. So when we're digging for coal, drilling for oil, production of fuels, things like that, we produce a lot of waste. So it's about 400 million tons of waste per year is what we're doing when we mine for minerals and some of those basic resources, minerals and fossil fuels, things like that. So the concern is, out of that roughly 400 million tons, about 60 million metric tons of it is classified as hazardous and toxic waste. So that's something we want to keep in mind, is that we're producing all this waste through the production of primarily fossil fuels, or extraction, I should say, of fossil fuels. And there's a lot of hazardous and toxic waste from the extraction of those fossil fuels. So think big picture here. If we can reduce our fossil fuel consumption, we can reduce the amount of fossil fuels we need to extract, which then reduces the amount of hazardous and toxic waste production. So it's a domino effect, and it all starts with consumption. Can we reduce consumption? All right. So now when we look at where does waste come from, take a look at the graphs below. That the pictures there. And we look at where does most of our waste come from. A big chunk of it's coming in the form of, not where does it come from, but in the form of paper and cardboard, paperboard, stuff of that nature. It's about 28% of the wastes that go into that trash can. Glass, you have metal, you have plastic, you have wood, you have food. Second largest chunk are yard trimmings that wind up in the waste stream. So we'll talk about this. Is there something else we can do with this? And honestly, one of the best things, if you guys mow your yard, don't bag it up. Cut it and leave it on the ground. Use the mulching feature on the mower where it cuts it up really small and it leaves it there. That actually fertilizes the yard, puts the nutrients right back into the yard, and you don't have to deal with trying to get rid of it. But we want to think about what form is the waste? In what form, what variety, what can we do with those things? Now, when we look at disposal methods, the challenge here is over half of our waste produced is going to a landfill. We recycle a little bit over a quarter of it. We compost about 8%, and then we burn, goes to incinerators about 12%. So the goal is to reduce this as much as possible, increase this as much as possible, increase this as much as possible. Incinerations, you might argue is better than landfill, but there are still problems with incineration. So let's say try to keep that where it's at, about the same, unless we can reduce it. So the goal is reduction in landfill and incineration, increasing in recycling and composting. Those are going to be the best thing, and reusing. So, all right, so let's take a look at this thing called the waste stream. Now, the waste stream it's a collection of all the wastes. So you get household trash that gets combined with industrial trash, that gets combined with commercial trash, and all this stuff merges together into a larger thing called the waste stream. And the challenge here is if all this stuff gets picked up and shipped in the same form, the same manner, it's supposed to be a little dump truck here, taking our waste, give a big bag of garbage, and it all gets mixed together and it goes to the landfill and then it gets dumped, you have all sorts of stuff mixing together. You have compostable materials, you have recyclable materials, you have toxins and pollutants and etc. That's all going to the same place. That's not good. The goal is trying to break this idea of, well, can we just simply just shove it all together? Let's separate it out. Let's take household trash, separate it into its individual components, move industrial trash to a different location, a different pathway, commercial trash the same way. So you create separate, smaller streams, and it's easier to deal with. You can deal with an industrial stream differently and more effectively than a stream where it's all mixed together. So again, the goal is identifying what's in the waste stream and then trying to figure out how to reduce the overall size of the waste stream. But in order to do that, again, we're probably looking at splitting it up, isolating it, and then tackling it in the smaller, isolated streams of household, industrial, and commercial. The challenge is that will cost money, and are people willing to pay for this, for the long-term benefits? So we're going to take a look here at where does waste go? How do we dispose of stuff? One common method in a lot of underdeveloped countries and sometimes in rural environments in the US is this thing called the open dump. This is absolutely horrible if you guys have ever seen them. Open dumps, literally people just start dumping trash on the side of the road. And if somebody did it, well, there's trash there. I'll just throw mine on the pile, and I'll throw mine on the pile, and they just keep piling it up. So the picture on the bottom left is in North Carolina. Locals just decided that's where we're going to start dumping our trash. There's a refrigerator there. There's a hot water heater, tires, all sorts of bags of stuff from the house that just gets dumped. So consider the environmental impact of that. Leads to major air and water pollution. When it rains, what's going to run out of there? If there's cans of paint, if there's batteries, there's all sorts of stuff in there that's toxic and pollutants. It's going to wind up in the local stream that people fish out of, that fills your aquifers, leads to some serious health problems. E-waste has become a significant issue in the last 15, 20 years. E-waste, here's a big check mark. This is electronic waste. A lot of our e-waste is getting shipped to less developed countries. A lot of toxic materials sitting there in your calculator, computer, old iPad. I don't need this cell phone, this flip phone, etc. And it just goes into the trash and gets dumped. And then less developed countries, a lot of people are salvaging out of that. They're going in there, busting open those computers, trying to extract the gold, the copper, the silver, the different minerals that are being used to create electronics. They're trying to salvage that for money. So we'll come back to e-waste a little bit later. But there's a lot of toxic materials in e-waste. Chromium, other things that are just not safe to be around. The goal for waste disposal method are the sanitary landfills. Okay, this is a big giant pit. If they're built correctly, they're lined with impervious layers that won't leak. And waste gets dumped in there and dumped in there and dumped in there, and it piles up, and then we cover it with dirt. We basically cover over the top of it and seal it up. The goal is, or the hope is, that it doesn't leak ever, that it all stays in there, and that the waste slowly breaks down, but a lot of times it's going to be there forever. Some of these things don't break down. Challenges, we're running out of room for these things. As the human population keeps growing, where do we keep putting landfills? Who wants it in their backyard? So this is the best disposal method, but it's not a long-term solution. When the human population was 4 billion, maybe that was more practical. But we're going to approach 8 to 10 billion in the next 20 to 30 years. That's not practical at all, to just keep digging holes, shoving it in the holes, and covering it with dirt. And then find a new spot to dig a hole, fill it with wastes, and then cover it with dirt. And ultimately, the big problem here is if these things do leak, there's some major hazards coming out of it. Not so much of an impact or application to the Midwest, but a bigger global impact is ocean dumping. It's sad. You go into the ocean and there are countries that will haul their trash out on barges and just dump it in the ocean. Ocean currents carry this stuff all over the world. Off the east coast of the United States, there's a gigantic circular swirl of ocean currents that create this gigantic circle in the water. And we're talking miles and miles and miles in diameter. And there's just trash floating in there that stays in that circle. It's like a big circular pattern of ocean current that is full of trash, and the trash will never leave because, here's the example. The ocean currents are doing this on a massively large scale, and any trash in there just stays and floats around. That's supposed to be trash. Just stays in this circle. So new trash that gets dumped eventually works its way over, gets caught into the circle, and it just continues to collect and build up and build up and build up. The damage this can have on marine life is unbelievable. You look at our poor bird over here, and the bird thought this lighter was something to eat. Bottle caps, pieces of plastic, all sorts of things floating in the ocean that the animals mistake for food, so they eat it. It doesn't digest. It's not coming out of its stomach, and it kills these animals. So lots of marine life make this mistake. Turtles love jellyfish. A plastic bag looks just like a jellyfish when it's floating in the water. When I've been diving and snorkeling, I've swam away from bags because I thought they were jellyfish, went back and looked at it and realized, that's just a plastic bag. Well, a sea turtle is going to eat that bag thinking it's food. So again, the goal is to try to minimize this. That's what we're going to talk about, is what can we do to shrink the waste system. So, okay, the last major method of disposal to talk about is incineration. This is also called energy recovery. This is where you take all your trash, dump it, burn it, because it's combustible, and that heat that is generated can make electricity. Steam creates steam for heating. You can use the heat to warm up your buildings or etc., or to just generate electricity that can then be used for whatever you need electricity for. So incineration is actually the second most common method of disposal, but the negatives on incineration is that it does produce, this is supposed to be some air pollutants, particulate matter, and some different pollutants that come out of incineration. So there's no perfect solution. It's just trying to figure out what can we do that will minimize that waste stream. So we'll be taking a look at that in the next lecture here.